Terrence O'Hanlon, CEO and publisher at Reliabilityweb and Uptime Magazine, coming to you from IMC, the International Maintenance Conference. Over the last 18 months, we've had an opportunity to train over 10,000 people on Uptime Elements, a reliability framework and an asset management system. And what's coming out of that work and what's going on at IMC and being expressed is a new context for reliability. A context that is reliability for everybody with no one left behind. The analog is very much like the way safety is treated in your organization. Of course, safety is not bound in a department. It's not owned by an engineering methodology or tool set. It's the way that you do business. In other words, safety for everybody with nobody left behind. That's the same context in which we've been applying Uptime Elements, reliability framework, and asset management system at companies around the world. What we're saying is that we need to change the way that we think about reliability. We need a new language set around reliability, and that's what's happening at IMC. So come and check it out. Join us in a brand new context for reliability and asset management. Reliability for everyone with no one left behind. Thank you very much.
John is already mic'd. He's got his lavalier mic on. My name's Jim Wilkinson. I'm the session chair, along with my wife, Susan, in the back there. We have some comment cards that are already handed out. The session name at the upper right the code is LZ14. Okay, and there's a basket in the back on your way out at the end of the session, or you can drop it into the basket. There's the no sales zone warning slips I just set one at the end of each row there in case anybody wants to fill one out. So that's about it. John Reeve, I met him yesterday at lunch, I believe, and he told me that this was my last best chance to learn about asset management here at this conference. So I like his confidence. And so he's here to talk about defect elimination. And John, if you're all ready to go.
Okay, I think this mic is working. You can hear me. This is an excellent turnout. It's even larger than the one I did yesterday where we talked about failure modes, the failure codes, and chronic failure analysis. So good stuff. This topic here has been presented and talked about by other individuals at this venue and previous venues. Of course, there's books on the subject by Winston Leday and Terrence O'Hanlon. That's part of the body of knowledge that they call it, the book set that they're at the front desk area. And it's critical reading material for the CRL. How many CRLs do we have here? Okay, yeah, maybe about a fifth of the audience. And a show of hands, how many plan at some point, maybe not this venue, to take the exam? Oh, look at that. All right. This is a uptime element, defect elimination. And it may be the most, in my mind, the most significant reliability initiative that no one knows about. How about that? Yeah. There's a lot of potential here. Now, I first found out about this listening, like you, sitting in the audience to a presenter talking about defect elimination, all right? And then at the next venue, I attended the manufacturing game by Michelle Henley, who is the daughter of Winston Leday. Michelle's not here, right? Okay, she's here, but not in this room. And they have a great game, again, called the manufacturing game, that explains what the defect elimination process is about. Program process, it's a process. And there are other companies out there that provide the same type of services. It's just that the Leday family has a large footprint here and obviously a lot of knowledge in those two books I mentioned. All right. Well, my background. So I am a CRL. Now I do mention Maximo quite a bit, but this is not a Maximo presentation. It could be about Oracle EAM. It could be about SAP PM. It could be eMaint, wherever Gregory is. Okay. All those other products. So again, I say Maximo, but please just insert the product that you work with. Yep, okay. I was the second consultant hired by the company that invented Maximo, so that's a long time ago. Performed numerous international assignments. I've published several journal articles. As you can see, some of them are cover stories. Yep. All right. And taught the first RCM for Maximo course at a customer site in South Korea. Frequent speaker, okay, fine. And hopefully I'll have a book out here this summer or fall. And my emphasis is, I believe there's two worlds out here. There's RCM experts, practitioners, really advanced in the world of reliability. That's my left hand, those RCM guys, you know, reliability engineers. And then we've got the CMMS professionals, like myself. That's where I started. And it seems like there's two worlds, and they're not communicating real well together. They're almost like opposing magnets. And so the purpose of this book is to break down those barriers. Yep. All right. Defect elimination from a CMMS perspective. So what is a defect? We'll cover that. There's a definition here. I'll bet you what you're thinking this moment. For those that, let me ask this question. Who in the audience is a first-time attendee to this particular topic? Oh my gosh. There's Michelle. Okay, so the point of that, why I wanted to see your hands was, if I'm sitting in your chair right now, my first thought is a defect. Well, it's something mechanical. The piping support is not supported correctly. There's leaking and so on. But a defect is much more than that. It could be a lack of skills, precision maintenance training. It could be the gosh darn maintenance procedures are not written correctly. There could be safety hazard issues, ergonomic issues, maintainability issues, safety issues, things of that type, yeah? Okay, and when I first sat in on the presentations by Michelle, being a CMMS guy, I'm always asking questions like, well, what's the difference between the defect and the work order? And so, again, that's part of this presentation, all right? And then who should we identify to remove the defects? We'll definitely cover that. And then this is something that Michelle would not cover, which is how do you configure the software for tracking these defects, right? And removing them, you betcha. So that's what we're going to discuss. Should we add anything else? We're good, all right. Let's move forward. Oh, this is a busy slide, yeah? So this is my picture. You won't see this anywhere else. This is my idea, my vision as to what an asset management system consists of. And I've got the 5 verticals from Uptime Elements, including the latest one, yeah? We have ISO 55000 up here at the top. And then these are my words. I break it into software, process, and organization very simply, yeah? And then from this, if you're creating Terrence doesn't like to use these words in the same sentence, but I sometimes do. A maintenance and reliability program. We're after reliability excellence, operational excellence here. So if somebody asked you right now what makes up that program, well, I broke it into 5 key elements, yeah? So here's our defect elimination, yep. Root cause analysis. Like I said yesterday, I talked about chronic failure analysis. That's really an advanced process that very few know about. And you could have purchased $1 million piece of software for your CMMS, and out of the box, it is not set up to do this, but it should be. Okay. RCM analysis. There are expert facilitators who conduct that, where they go to a site and they focus on a particular building, plant, or system, and they will study all of the assets and determine their applicable failure modes, and from that, the proper maintenance tactic. Okay. Condition monitoring, also called predictive technologies, that includes vibration analysis, infrared ultrasound, and many other things, oil analysis. Advanced work management process, this is really the guts of the CMMS side. Obviously work management, inventory management, materials, purchasing, invoicing, planning and scheduling. Yep. So we'll talk a little bit about that. What the whole purpose here is to create a true knowledge database from which you can solve problems quickly and effectively. You have competitors in the business model, in the industry. This very moment, they may be doing something better than you. They're trying to put you out of business, perhaps, maybe. So you always want to be thinking in a competitive mode, and the CMMS database can help you provide answers, analytical answers, to arrive at decisions quicker than they can. All right, so yeah, the software may be world-class. I don't care how much money you spend on it, but you cannot purchase reliability. Those are my opening remarks. Any thoughts so far? Okay, I do welcome interruptions at any time. You can say, hey, I got a question. All right. So software is straightforward, consists of the data, but the process consists of standard operating procedures. A RACI chart, who knows what that is? Maybe? Anyone? Okay. Oh, a lot of people. So responsible, accountable, consulted, informed. The key two, or the first two, responsible, accounted. So the technician might enter the failure code on the work order when the job's done, but the supervisor may be held accountable for its accuracy. It all depends how you write your chart. Okay. Business rules, yeah. Business rule might say, well, at the end of the shift, maintenance technician, even though the job's not done, you are accountable for updating that work order in terms of the man hours. I don't want the man hours put in tomorrow. I want them put in before you go home. Okay. However you write your business rule, yep. Organization, hopefully you have leadership involved, executive sponsors, you know, and you should have a core team running your CMMS, and a reliability team. Anyone here have a reliability team? Okay, we've got about 2, 3, 4 hands. Thank you. Take a look at this after this venue here and start investigating what that's all about. I have content on it, but if you have an failure analytic, I mean, who are you going to give it to, right? And so these guys would be involved in evaluating your chronic failure analysis. Maximal admin, power users, planner schedulers. Okay, fine. Let's move on. All right, defect elimination. I think I said this already. May be the most significant initiative within the reliability program, striving for reliability excellence that nobody knows about. Okay, and it can provide the largest return on investment, in my opinion. Okay, as a process, it identifies and then analyzes the defect. It repairs and removes the defect, implements corrective actions to prevent future occurrences. This is interesting. Yeah. Okay. We'll talk about that more. Okay. Yeah. All right. So here's Winston. These are his 2 books, and they were fun to read. It's a fictional story, but it's a very realistic story. Yeah. I wrote down the plant manager's name. James Emery, okay? So within any organization, you have a lot of personalities. Even the plant manager, he can struggle with his the reports that people that report to him, rather. And they have different ideas on how to improve maintenance, how to reduce reactive maintenance. Some people will say, well, if you just implement better planning and scheduling, we can fix all of our problems. Okay, well, that's not true. I mean, you could be 100% compliant on your PM schedule, but be doing the wrong maintenance work. Yep. And furthermore, too much PM actually induces failures, or can, due to lack of skills training, precision maintenance training. Again, these are called defects. Yep. Okay. Yep. Okay. I'm just looking through my slide here. So I was sitting right here. You can see my name, right? So I stood back and took the picture. This guy was real excited. He's, I don't know why, but he was a Maxwell administrator from University of Minnesota, I think. And there's Mr. Henley. Okay, all right. Very good. All right, so it's not really a commercial. I'm just stating a fact. This organization is always here at the Reliabilityweb venues, and they provide this manufacturing game training. It's all free, and it helps introduce anyone, myself included, to what the heck this is all about, and the facilitators here walk you through the program, and you get familiar with defect elimination real quick. When I did this game, I had an advantage because I had already read the books coming into it, and so I knew that don't get trapped into thinking planning and scheduling is going to save the day. Yeah, okay, so I had an advantage over the other students. All right, now there is another firm here. I mean, there's probably others. And so the point is you're focusing on defect elimination. So what is their strategy? They tag all defects no matter how small. They tag leaking areas. They clean, check, look, and ask. They look for loose electrical conduit, leaking hoses, etc. They have a term called basic equipment care. They focus on system walkdowns. They don't provide this manufacturing game or anything similar. So that's quite unique, as far as I know. Okay. Yep. So there's different ways to get from A to Z. Let's move on. So they focused on a particular system within the plant, maybe, for a 4-week period. So that would be one of the inspectors. And he's hanging red tags, right? Okay. So I'm trying to show you how this process would work. Oh boy. Okay. So eliminating defects, and this is a slide that shows you more examples of what the defects are. I may have copied this from one of the passports or from somewhere. Anyways, it does look like it. Deficiencies in the PM program. In other words, the PM maintenance strategy is incorrect, maybe, or it has some missing steps, or it's poorly worded, or the frequency is incorrect. It could be a duplicate PM, all sorts of things. Okay, deficiencies in maintenance repair overhaul procedures. Yep, the procedure, you could have an excellent tech, but he did something wrong because why? Because the overhaul procedure was incorrectly worded or poorly worded, yep. Deficiencies in the way the equipment is operated. Well, when we get into the likely cause codes for asset failure, the largest contributor is the operations side. Do we have any operators here? Oh boy, okay. All right, so deficiencies in equipment design, deficiencies in equipment manufacture, deficiencies in the way the equipment's installed. Well, this is the vendor installation guy maybe and commissioned. Deficiencies in the specifications for spare parts. So if you give a poor specification to the buyer, whose fault is it that he buys the wrong part? Okay. Yep. And then the part, the bearing is delivered on a flatbed truck over a very rugged road with a lot of potholes in it, and it maybe wasn't set down too well securely, and it caused damage to the bearing during the delivery. Where am I pointing at? Yeah, so that's delivery, but this is also can be poor storage procedures, yep, and preservation procedures. And then deficiencies in maintenance skills. So here's a term. Who knows the term or who has heard the term precision maintenance training? Okay, maybe 40, 50% of the attendees, yeah? For the others, this is definitely a best practice, and it's not necessarily an uptime element, but you will hear it discussed by various professionals, presenters, and so on other topics. So I am at a university performing consulting service, but along these lines, and their directors, the leadership team, requested an outside organization to come in and conduct precision maintenance training for all of their maintenance techs. This is a university, yeah? So the people can be good, but even if they've been there for 10, 15, 20 years, you don't know if they have some bad habits or not. And you definitely want to make sure the young guys are trained, because mentoring doesn't always work as well as it should, okay? Precision maintenance, I mean, that's a topic in itself, and I don't think we've got time to discuss it now. But anyways, okay, what else we got here? Yep. Okay, so we want to identify defects in the plant, but also utilize our failure analytic to identify our worst offenders and start drilling down on the failure modes there. And once we start looking at the cause codes, we might find defects. That's interesting. Okay. All right, so now I'm starting to link this to the CMMS product. I know this screen is too small for you to see. I mean, I can barely see it from here. But I'll get to a slide later on that shows the entire screen in large size. All right. All I want to point out are these two things here, a defect type and discovery type. Now, I invented this. I'm not sure it's from anyone else, so it's just my idea on how we should start coding these things, right? So defect type. The defect was identified and corrected on the spot, and that's the ideal model, right, Michelle? Sometimes a defect is identified, but it's rather costly. Now, so a business rule would be provided to the defect elimination team saying, if it's over $5,000, it's still okay for you, the team, to go after it, but we do need to convert it to a work order because we'll need to request a purchase order to get that going. Otherwise, if it's under 5, maybe they have these little cards, what do you call them, P cards, and they can just go purchase stuff locally, yeah? What if this defect, quote unquote, they discover is not something they can take care of right now? It requires some engineering analysis. All right, so we got to give it a label. I use the term deferred. Maybe that's the wrong word. Maybe you have a better word. But if you go with me right now, I'm just labeling it. It's something we can't do yet, but I don't want to lose track of it. Okay? And that would go into this screen. All right? Here's our discovery type. Now, how did I discover it? So when I'm in the manufacturing game listening to Michelle talk, they're talking about the defect elimination team discovering these things. Well, you could also discover it when a tech's performing a PM inspection, yeah, and maybe even a normal repair job. So a defect can be discovered at any point, and maybe there's some value report-wise to categorize this as a discovery type. Maybe there's a fourth one here, right? Okay. Thought that's the only 2 points on this screen? Or what do we got here? That was it. Fine. Okay, work order feedback. So I'm using a software package, and you know what it is. But as good as that product is out of the box, there's no work order feedback screen. Doesn't exist. Okay, the power of the product is for you, the user, to design what a feedback screen should look like, and you present that to your IT staff, and you say to them, can you go configure your software to give us this functionality? All right, so assuming that happens, let's talk about what's up here. Okay, so the techs, these guys have a lot of knowledge, as well as the operators. Yep. We just got to ask them. And if you, who considers themselves middle-level management or supervisory frontline? Show of hands. Okay. So if you don't ask the techs for this information, they're not necessarily going to provide it. Or they do provide it, but it's in text format on the work order. They write it in text. I cannot write a single analytical report off of free format text. I'm glad they did it. They gave me valuable information, but it's hard to manage it. If you put it into a validated yes-no field, like this, and then explain what the yes means, I can electronically route this to the appropriate people. Maintainability issue, or design issue rather, who am I going to route it to? I'm going to route it to an engineer, maybe a reliability engineer, right? You probably won't have a design engineer at the plant. Anyone here in the wastewater business? All right. All right, so you know what this thing is, an Archimedes screw pump, yeah? Okay. Lower bearing needs oil lubrication instead of grease lubrication, so therefore it's a design issue. And off we go. You'd be surprised what the techs know, don't know, yeah? Just ask them. Okay, let's start at the top. So they may discover a safety issue. The planners plan work orders. Is it possible they missed something about the asset? Yeah? You got out there and you discovered that there's a handrail missing, and you got to get to the top of this tank to do this gauge reading, right? Okay. The task wording is poorly worded on the job plan work order, yep. Identifying new failure modes. All right, well, we haven't really defined what failure modes are, but you could probably guess it's symptoms, problems associated with an asset and component. Poor work order estimate, so, and we're getting a bit nitpicky here, but it's valuable information. So the craft is telling us that you estimated this job to take 2 hours, it takes 6. Give me a break. I mean, you're going to do comparison analysis, I'm sure, in management, telling us how bad we were because it took 6 hours. Well, the estimate was wrong, our opinion. Okay. Incorrect frequency, incorrect strategy, asset condition. Okay, I like that subject right there, asset condition. So, again, the out-of-the-box product I use does not have a field on the work order screen for capturing asset condition, but I think it should, especially in the utility spaces industry. So what would the procedure be? Whenever you're doing a monthly PM, have a business rule that says, give us an asset condition, a grade 1 through 5. 5 means it's runs like new, even though it's 20 years old. 1 means it's barely surviving. There's a lot of occasional repair work jobs going on with it. Okay, and you can decide yourself if you want to capture that as either as found or as left, or maybe you do both. And then you can trend that. So that's feedback, and it could be considered a defect. Wise information. Maintainability issue, definitely. Missing failure. Now, we're missing failure problem code data as well as asset location data. This is foundation data on the CMMS. This happens. So, as good as the implementation team was, the foundation data, you're missing assets, and the technicians do discover this when they're out there in the field. And now we're giving them a way to report this. All right. So this is my work order feedback screen. In my opinion, it sort of ties into the world of defect elimination. A question, please. Yeah. Yeah, there's I gotcha. There's a couple ways you can do this. You can hijack the failure reporting tab on work order. Yeah. Or you could just make a new application, a Power App. You can make a new Power App in a couple of days. But the real magic here is electronic workflow off of validated yes-no fields, routing it to the correct individual, whether it's a reliability engineer or a maintenance supervisor or whom. So that's all going on behind the scenes. And if the technicians find out that they go to the effort to provide feedback and then you, middle-level management, don't act on it, or at least respond to it one way or another, they will stop giving feedback. And then everyone loses, right? Okay. Thank you for that question. Did I answer it? Okay.
Can I make a comment? I've never seen the asset condition before on the feedback. I find that interesting. Where I have seen it quite often is for calibrations of instruments. So you want to know how far it's drifted or the variance.
Yep.
Then you calibrate it and helps you determine better the frequency of
Yeah.
recalibration and why it drifted. First time I've seen asset condition.
Okay, so I'm going to take that as a compliment. So yes, it's definitely applicable to calibration world, but imagine you are an asset manager for a water wastewater utility with miles of linear pipe. And then they got these occasional concrete underground, well, they have a name for them. You can walk into them, and that's where all the pipes connect. So they have to grade those things. And so the public wants to know the condition of your assets because you're asking for capital money every so often. See, it all ties together, huh? Thanks for that. This is an extremely valuable parameter, and I use it in chronic failure analysis. Yep, okay. All right, well, this slide, again, I stole this data from other sources, and I was really shocked by these numbers. So aging asset can last 25 to 50 years, at least it should. So sometimes though stuff happens and it will fail due to aging, but per studies, that's only 4% of the time. Okay, so if you have a car and the tires wear and tear, well, that asset, the component in that case, will 12% of the time, all right? But this 84%, what the heck is that? That's a gosh darn big number. Okay, so 84% is human factor, also called carelessness. So that's why they call it ABC, aging, basic, and careless. Human factors, 84%. So in your CMMS product, we should be really focusing on these cause codes. I'm not sure we do. Yeah. What's a typical thought process, we'll say maximal in this case, when you're putting in the cause code? You're on the failure code section, and okay, I'm going to put the cause code in, and I type in bearing. The poor bearing didn't cause the problem. Just don't blame the bearing. The bearing's fine. Well, it would have been fine, but you stopped lubricating it a month ago. Okay. Or you introduced contaminant into the lubricant. All sorts of things. So we don't want components in the cause codes. This is where you're going to make your improvements right here. Now, 84%. Don't take these numbers and try to add them up to 84, because that doesn't work. These add up to 100, so okay, fine. I mean, yeah. All right, so what's the biggest number in this list? Who should we blame in the room? Stinking operators. No, I'm sorry. Sorry. All right. I didn't mean that. All right. So, but right behind them, very close behind them, we've got maintenance techs, and then raw materials handling, right, storage, and then inferior parts, design. You know, a lot of ties. Okay, so we're going to drill into this. What else we got here? Oh boy. Now again, this is my invention. It's a busy slide, but there's a lot of valuable information here. This PowerPoint is a PDF that should be downloadable from the Reliabilityweb site after the venue, even right now, yeah? Okay, so I've configured Maximal. I've added fields to the work order screen, failed component problem, but more importantly, I've added the cause 1, cause 2, cause 3, and cause 4. So let's talk about these. I'm going to walk over here. Hopefully that speaker won't react. I'm blocking you guys.
Yeah, you're good.
Okay. All right, I can see this. All right, so, all right, we'll put in a mistake was made. There's really no defect. Okay, fine. Force majeure means a tornado came through the plant and caused some damage. That's that. Normal wear, okay, we saw that on the earlier slide, right? And then aging. Aging was 4%, and I think normal wear was 12%. You could have a power failure or a surge, and that in itself could introduce a problem. I mean, I've lost an oven at the house because we had a power surge from the stinking power company. All right. Anyway, other causes. So if it's not any of those black boxes, it must be this red box. So now at that point, you must enter cause 2. If you choose this, you must populate cause 2. All right, so now what's over here? So now we're talking human influence, right? Here's our storage handling, vendor setup, design flaw, management oversight, poor housekeeping, operating the asset, and we know who those guys are. And then improper PM cycle, PM skipped. If it's not any of those black ones, now we must choose workmanship. All right, and so now we're over here. And you can read that. Now, some of you in the audience may be thinking right now, well, I'm not sure that techs are able to put this information in the system. I mean, how are they supposed to know that moisture was introduced necessarily? So correct, the thought process is correct there, and it is a concern. And so maybe we do this differently. Who would put in this data? It might be the maintenance technician, and then he's done. Maybe here, procedurally, you have the maintenance supervisor put in this value, if this is required, right? And then here, maybe through electronic workflow, we require the reliability engineer or maintenance engineer to put in this answer. He may have to go out to the plant to investigate, right? A good chance. Now, we're not doing this on every work order that comes back. We don't have to do it on a PM because there wasn't a functional failure. We're only doing it on repair jobs that have a functional failure. And maybe to start out, if it's overwhelming to your organization, maybe you start out with a business rule that says, let's only go after our top critical assets. All right, then as we get comfortable doing this, we start opening it up to all assets if there's a functional failure. Okay. Now, let's say this right here is the third element field of the failure mode, which is the language of RCM. You could replace the bearing this week, say tomorrow on Thursday, right? 3 months from now, that same bearing can fail in the same asset. Same asset, same bearing. Well, why did that happen? Because we never addressed the human oversight area here. Now, this would be a determination by the maintenance supervisor or the reliability engineer as to whether or not they should pursue this analysis here. So if they decide to pursue it, the conversation might go like this. So the maintenance supervisor knows who the tech was. He would bring him into his office and have a conversation. The door's shut, so no one else is listening, involved, and so on. So it's a one-on-one conversation. The supervisor needs to find out, is there a skills deficiency? That's an honest question, right? And so if it's skills deficiency, well, the fault's on management for not training the tech properly, yeah? Okay. Maybe the supervisor assigned the wrong person. He has a proper skill set to do this job, but he wasn't thinking right. He assigned the wrong person. You were short on resources, and you were hoping it would work out. You know, it didn't. Lack of motivation. Okay. Systemic cause. Maybe there was never any training provided. Maybe the procedures are inaccurate. No repair standard. Latent cause. Now, this would be really bad here. 10 minutes. Wow. No value seen in precision maintenance. Okay. So this is where the front line, the maintenance techs and operators, they know where all these problems are. But if you ask a senior manager, he's only going to know about 4%. Yeah? Okay. Safety proofing. All right, anyone here in the military or U.S. Navy? All right, and do you ever work in engineering spaces? Absolutely? Okay, great. Did you ever drop a wrench in the bilge? Okay, well, well, good. I heard, okay, reactor operator. So I was lower level engineering, and I did drop a wrench, and there's no way you can retrieve that wrench once it goes in the bilge, unless you're on a Sunday cleanup. All right, but this is clever. I saw this on the internet recently, and so there you've got a wrench, and look at this. Isn't that nice? I would not have dropped the wrench if I had that. This is called safety proofing, and it falls under defect elimination. Safety proofing. How about that? Defect team. Okay, so we should have the key point here. If you anything you take away, the most important thing you take away from this session is establishing a cross-functional working group. So you want the techs involved, obviously, but maybe even an operator and maybe even an engineer, right? And they want to identify defects. You focus on. You need to make a decision. Where are you going to focus? Is it one particular system in the plant? Is it critical equipment? Okay. So you do that, and then you start identifying these defects, and the goal is if you can correct the defect right then and there, go for it. Yeah? Okay. So in some cases, you need to come back at the end of the day or even at the end of the week as a team, and you discuss amongst yourselves. There's no senior managers in this team. You're discussing at the working level what is more important, where's the most benefit, how can we eliminate the most risk. You make those decisions. You are empowered as a team to do those things. Okay? All right. And here's the screen. Okay, so this is very busy, obviously, and this will be in the PDF that's downloadable. But we can assign a priority in this format here, a priority. So critical, major, minor, incidental, yep. And we can do a categorization. So here's 10 through 99, and you can see the wording there, parts with defects, design flaw, etc. So this is an extremely valuable way to categorize, slice and dice the data over time. Yep. This was an operator. You know, so as an organization, you've got to make a decision. Do you continue writing this information in the operator shift log notes? Or should stuff of this type be peeled out and put into the defect screen? That's a decision. You've got to figure this out. Okay. Isn't that nice? All right, so here we've got the things we've talked about, you know. So here's those 5 categories they're coming in. All the time they're coming in, unless you start eliminating these with your defect team. And here's our aging and normal wear. They're coming in. So these are causing problems in the plant. They're causing unplanned maintenance, right? And every once in a while, the defect team is successful in eliminating these things. All right. So the whole point of this slide is you want to get to the point where you can eliminate more than is coming in. What's next? All right. This is the PF curve. I think you've seen it before. The most important point here is the precision maintenance training emphasis. That really helps eliminate defects. Okay. All right, so we're about to wrap up, and this is the most important part of the venue. So we've got a reactive domain. Anyone here that would admit to it that they're currently in a reactive domain? Okay, all right, I'm sorry. Now, there may be someone in your organization right now that says, you know what, if we just implement better planning and scheduling, we can fix this, I promise. Well, that's not true, as I said, and I'll show you. Now, per the book and where we want to end up with the defect elimination model is in the 3rd domain, which is called the precision domain. Yeah? So at this point, the maintainers are in charge, not the equipment, right? The maintainers are in charge, and we have minimal unplanned breakdowns. Our teams are active in finding and eliminating defects, and they're introducing the every 1 out of 100, eliminate, make it better. and the staff is able to concentrate on finding defects and stay ahead of the game. Now, here's the reactive domain. So if this is, you raised your hands a moment ago, this is you. You have a lot of breakdowns and you have general repair going on, and that consumes all of your staff. That's your staff availability line right there. 5 minutes. I can do it. I can do it. Okay. All right. So here we go. Now we're in the planned domain. We're in the planned domain. Okay. Now we're starting to do overtime. Well, sometimes the tech's like that, but you know it's not always good for the organization. So we're exceeding our 100% line. We're doing the PM that you wanted us to do, and we're doing the condition monitoring predictive technologies, okay. But we still have this here. We still have general repair and breakdown. What are we going to do? So we implemented this, but it didn't necessarily stop this from happening. Performing more PM does not necessarily remove all the defects. Okay. Now, this was my interpretation. The precision domain, I broke it into 2 slides. And so you want to implement this gradually. And in the book, so James Emery, what he did was he essentially turned off the Maximal system. Not exactly, but I'll start with that statement. He turned off the general repair you don't see here. So they're just holding that off. They will obviously still do breakdowns, and they'll do mandatory PMs that are high criticality, right? But they're really focusing on the defect of limb to get a handle on that. If you're with me so far, let's go to the next slide, which is domain 2 of precision. Now we've got a good handle on the defects. They are really reduced now. The breakdowns are also dramatically reduced. We'll still have some general repair, but now we've got enough man hours in the day and the week to do proper PM and PDM. And that's my theory on how to get a handle of this. So you really have to go after the defects. All right, this is the last slide. We're going to stop here. Again, this slide was created content-wise by Winston and Professor Mark Page a long time ago. And the whole point is you can implement planning, open the champagne. You can implement scheduling, open the champagne. You can do them both. Look at that. It actually provides a negative benefit. But if you do all 3 tactics, and the third one is defect elimination, you'll get the largest increase in plant uptime, believe it or not. Don't try adding these numbers together either. That screwed me up for a long time. All right, so, and if you do all 3 together, like the previous slide I just showed you, that's our 19.9% benefit with defect elimination. That is how you can improve proactive maintenance and reduce reactive and implement or go after defects at your plant. I wish you the best of luck. I hope this added some thoughts for you to consider, and good luck on your future endeavors. Thanks.
If anybody needs, thank you. Thanks, John.